Welcome back. Techniques used in data science. Here are some commonly used techniques in data science: data cleaning and pre-processing. This technique is very crucial when it comes to data science. Data cleaning involves identifying and handling missing value, outliers, and inconsistent data to ensure that data quality is enhanced. Now, we know that most of the data that we deal with in data science are very dirty, and so we need to clean them. So the process of making this data cleaned is what we refer to as data cleaning and pre-processing. Now, we need techniques like imputation, outlier detection, and data normalization in order to pre-process the data before analysis. Another technique is exploratory data analysis. Exploratory data analysis, also known as EDA, involves visually and statistically exploring the data to understand its structure, the patterns, and even the relationships that exist in the data set. So techniques such as summary statistics, data visualization, correlation analysis, and distribution analysis are used to gain insights and identify interesting trends or anomalies, or what we call anomalies. Another technique is statistical analysis. Now, statistical analysis involves applying various statistical methods to analyze data and then draw meaningful conclusions from your analysis. The techniques include hypothesis testing. You have to test the given hypothesis. You can conduct a test, ANOVA, regression analysis, time series analysis. These techniques help uncover relationships. They can also help you to assess significance and make inference about the data. Another technique that you need to understand is feature selection and dimensionality reduction. Feature selection techniques aim to identify the most relevant and informative features in the data. Now, you need to carry out your feature selection so that you'll be able to differentiate between the dependent variable and the independent variable. So this technique is very crucial so that it will help you to identify the most relevant and informative features that you need in order to carry out your analysis. Now, this technique as well, which is feature selection and dimensionality reduction, will also help you to reduce noise, improve model performance, and avoid overfitting. Now, your overfitting is a situation whereby you have trained your model, and the model performs well on your system, but when you want to test it with unseen data, you discover that that model could not predict anything. That is overfitting. So techniques like correlation analysis, feature importance, and recursive feature elimination are used for feature selection. Another important aspect, the second part of it, is the dimensionality reduction techniques like principal component analysis and TSNA are used to reduce the number of variables while preserving important information. Now, you might be given a very large data set, and these large data sets, you need to reduce them. That is when these dimensionality reduction techniques will come in, and you can use what we call PCA, which is principal component analysis, to do that. Also, another technique that you can also use is your TSNA, which is also a model that can also help you handle that. Another techniques that we need in data science is machine learning algorithms. You need to understand your machine learning algorithm, because those are the tools or techniques that are going to use to build predictive models and also make accurate predictions or even classification. Commonly used algorithms in machine learning include linear regression. Now, your linear regression will try to examine the relationship that exists between your dependent variable and the independent variables, as it were. Then another algorithm in machine learning is logistic regression. We also have decision trees, random forest, support vector machine, k-nearest neighbor, and neural networks. The neural network is a deep learning network that works exactly like the human brain. These algorithms learn patterns. They learn patterns, they learn relationship from the data in order to make predictions on new and unseen data. Further technique that you need is model evaluation and validation. After you have trained your model, you need to evaluate the model. That's what we refer to as model evaluation and validation. Model evaluation techniques will assess the performance and the generalizability of your predictive models. Common evaluation metrics that we consider include accuracy. You need to know the accuracy of your model, the precision, the recall, the F1 score, the ROC curves, and also even the cross-validation techniques. Now, if you don't do this, you might not be able to ascertain the validity of your model. So proper model evaluation ensures reliable and robust predictions. Very, very important technique that you need. Another very important technique is text mining and natural language processing. Remember that text mining and natural language techniques, also known as NLP, are used to analyze and extract insight from text data. So when you are dealing with text mining, you need NLTK packages that will help you to go deeper into your text, you mine, and then you do analysis. So what you are doing in essence is to do what? To analyze and extract insight from your text data. Text data are different from numerical data. And then techniques that you need in this regard include text processing, tokenization, breaking your large chunks of data into tokens. You can also do sentiment analysis, topic modeling, text classification, name entity recognition. These are tasks under text mining and natural language techniques. You also do what we call text summarization. All these techniques enable understanding and processing of unstructured text data. Let's assume you are given million lines of text, or maybe like customer feedback or customer reviews. You need a natural language toolkit to be able to examine the text, then be able to extract sentiments from those data sets. That is where natural language processing is very important. That you need it. Then another technique is clustering and segmentation. This is also part of our journey to become a data scientist. Clustering techniques will group similar data points together based on their characteristics. Algorithms like k-means clustering, hierarchical clustering, and DB scan are used to identify patterns, identify, also segment customers. So when you talk about clustering, clustering will try to do what? To identify patterns. When you talk about segmentation, segmentation aspect of it will try to segment customers, group similar items, or also discover hidden structures in the data. There is a very, very, very good and crucial techniques that you also need as a data scientist. Another technique is time series analysis. Time series analysis techniques are used to analyze and forecast data that is collected over time. So from the word time, we are talking about data that is collected over time. The techniques that are very common with time series analysis include trend analysis, seasonality decomposition, autocorrelation, moving averages, and even exponential smoothing. These are techniques in time series analysis. Now, time series analysis is commonly used in forecasting stock prices, sales weather patterns, and other time-dependent phenomena. That is time series for you. Another technique is deep learning. Deep learning techniques, particularly the neural network, are used for tasks like image recognition, natural language processing, speech recognition, and even recommendation systems. So deep learning techniques are very, 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 very important when it comes to data science. Now, deep learning models can learn complex patterns and representations from large amounts of data. Can you hear that? That is why deep learning is an advanced form of machine learning. You will be, the deep learning models have this ability to learn complex patterns and representations from large amount of data.